Okay, let's just think about this for a second. Almost everything in the physical world, the phone you're holding, the chair you're sitting in, the buildings all around us, is on the verge of being completely reinvented. We are right in the middle of a massive fundamental shift in how we create, well, stuff. And the engine driving all of it is artificial intelligence. And just to give you a sense of how dramatic this change is, think about this. The old way of discovering a new material, that could literally take a scientist's entire career. We're talking 10, maybe 20 years of painstaking trial and error. But today, AI is squashing that whole timeline down to just a few months. And sometimes, even a matter of weeks. It's an incredible acceleration, and that's the revolution we're going to unpack today.
So here's our roadmap. First, we'll look at this brand new AI-driven design paradigm. Then we're going to hit an unexpected plot twist, the great innovation bottleneck that this created. After that, we'll check out the solution, self-driving labs. We'll see some amazing breakthroughs happening right now in the real world. And finally, we'll take a peek at what's next, the coming quantum leap.
Right, so for basically all of human history, finding new materials was kind of messy. It was a mix of intuition, happy accidents, and just a ton of trial and error. But that whole era, it's coming to an end. We're shifting from a world of luck and serendipity to one of truly intentional design.
And the key idea powering this whole shift is something called inverse design. It completely flips the script on how we used to do things. See, instead of making a material and then testing it to see what it can do, we now start at the end. Scientists can say, okay, I want a material that's as strong as steel, but also completely biodegradable. And then they turn to an AI to work backward and figure out the exact chemical structure that's going to give them those properties. What's so amazing is how beautifully simple the process is, at least in theory. Step 1, you just tell the AI what you want. Step 2, the AI dives into this near infinite universe of chemical possibilities and comes back with the most promising options. And step 3, scientists get to skip all the guesswork and just focus their time and money on making the best of the best candidates. It's just so much more efficient. Basically, what we're looking at here is what a lot of people are calling the ChatGPT moment for the physical world, right? Just like those language models suddenly gave everyone access to powerful AI, these new tools are letting a whole new wave of researchers and even startups design incredible new materials, sometimes right from their laptops. But, and this is a big but, this incredible success story has created a totally new and kind of ironic problem. We've gotten so good, so fast at designing materials in the digital world that we've accidentally caused a huge traffic jam in the physical one. As one expert put it, the bottleneck isn't dreaming up the ideas anymore. The real problem, the new challenge, is actually finding the time and the resources to physically make and test all of these amazing potential materials the AI is coming up with. To put it as simply as possible, the AI is just too fast. Our traditional labs, with humans working at a human pace, just can't keep up. We're coming up with brilliant ideas way faster than we can prove they work in the real world. And this chart really shows you what's happening. On the one hand, you've got this massive, soaring bar for digital idea generation, all thanks to AI. And then, way down on the other side, you've got the much, much smaller capacity of our physical labs doing manual testing. That gap right there, that's the great innovation bottleneck. So how in the world do you solve a problem like that? How do you fix a jam where the digital world is just lapping the physical one? Well, you build a bridge between them. And that brings us to the self-driving lab, which is where AI gets to team up with robotics. A self-driving lab is pretty much exactly what it sounds like. It's a completely automated system. You have an AI that acts as the driver. It designs all the experiments. Then you have robots in the lab that are the hands. They physically mix the chemicals and run the tests. And the most important part? The results are instantly fed right back to the AI, which learns from them and immediately designs the next experiment.
This creates this incredibly powerful closed-loop discovery cycle. The AI designs, the robots execute, the AI learns, and it just goes round and round and round, 24/7, with no need for a human to be there. This is how you close that innovation gap. This is how you match the speed of the AI.
And hey, this isn't some far-off sci-fi concept. It's happening now. Over at Argonne National Laboratory, they have a system called Polybot. Its job was to figure out the best recipe for making electronic polymers. We're talking about a search space of nearly a million possible combinations. No human team could ever tackle that. But Polybot, it just autonomously worked its way through that massive landscape and found the absolute best recipes for creating highly conductive materials.
Okay, so we've got a new way to design materials and a new automated way to test them. So what? What does this actually mean for you and me? Let's look at some of the incredible breakthroughs that are already making the leap from a computer screen into our physical world.
Here's a fantastic example. Researchers at MIT and Duke used AI to sift through thousands of potential molecules to find one that would make a material stronger. The result? They came up with a new polymer that is 4 times tougher and more tear-resistant than what we have now. And get this, the AI didn't just find a better recipe, it actually uncovered a whole new scientific principle that the humans hadn't noticed before. This kind of innovation is also making our buildings way smarter and more sustainable. People are developing self-healing concrete. I mean, come on, it uses bacteria that live inside it to automatically fill in its own cracks. And we're seeing smart windows that can go from clear to opaque with just the flick of a switch, which can block out the hot sun and massively cut down on air conditioning costs. And this isn't just happening in huge university labs either. A whole ecosystem of startups is popping up to turn this tech into real products. You've got companies like Symboli designing custom polymers for better packaging, Reblock making low-carbon concrete from old waste materials, and Restore 3D using AI to 3D print medical implants that are a perfect fit for a specific patient. The applications are just all over the map. Now, AI and robotics have already been a total game changer, but there's another piece of tech coming over the horizon that promises an even bigger jump forward, and that's quantum computing. This is all about simulating reality with perfect, pinpoint accuracy right down to the level of individual atoms. Now, here's the thing to understand about quantum computers. They aren't just faster versions of the computer on your desk. They work on totally different principles. This allows them to solve certain kinds of problems, especially in chemistry and materials, that are just mathematically impossible for a regular supercomputer to ever solve. Doesn't matter how big or powerful you make it. This really gets to the heart of the difference. When a classical computer simulates a molecule, it's making a really, really good guess, an approximation of reality. But a quantum computer can model those quantum interactions directly. It's like the difference between reading a description of a baseball game versus actually being on the field playing it. And having this power, well, it could help us solve some of humanity's absolute biggest challenges. We could discover the perfect catalyst to pull carbon right out of the atmosphere. We could design revolutionary new batteries for clean energy that last way longer. We could even completely change medicine by perfectly modeling how a new drug will interact with a specific protein in the human body. So the real big takeaway here is this idea of convergence. None of these technologies are working alone. The future of science looks like this integrated, seamless, closed-loop system where an AI dreams up an idea, a quantum computer simulates it perfectly, and a robotic lab builds and tests it in the real world, over and over, faster than we ever thought possible. This whole revolution is giving us a power we've never really had before as a species, the ability to create new physical materials almost at the speed of thought. It's a truly profound new capability, and it leaves us with an equally profound question. With the power to build almost anything we can imagine, what will we choose to build first?